and then I'll start the session in about 15 seconds.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning. This is Steve Cantrell with DBA Fundamentals. This is our third virtual chapter meeting of January. Today we have a special treat. Our sponsor with SentryOne, Kevin Kline, will be presenting FIRE, a foolproof checklist for tuning and troubleshooting. I've got a few housekeeping things to take care of, but let me get started with that. Okay, our sponsor is SentryOne. Kevin's got some stuff in his slide deck that he's going to talk about, so we'll just continue. PASS has a number of virtual chapters. There's so many now I don't even remember, but there's one for most major topics and most major languages, so go to sqlpass.org/VC and check it out. Here's our sessions coming up. Next month we have Aaron Stellato with answering the question, what happened with the query store? And we have two other sessions, partitioning basics and stored procedure optimization techniques with Kimberly Tripp. Those are going to be awesome sessions. Normally I try to show some of the other selected sessions around PASS, but we had a major migration this weekend, so I spent a lot of time with that, so I didn't get around to doing that. But if you'll go to the virtual chapter section of SQL Pass, you'll be able to go in there and find other sessions that are coming up. I had, on one of our emails, I'd said that we were going to be giving away $500 at the end of June. We've had to change that a little bit because we found some of the money that we received from the stuff we won with the code usage last year has to be used by March 31st. So with the $500 we had, we added $200 to that, and we're going to break it up into, for every session that you attend of DBA Fundamentals in January, February, or March, you'll be entered one time, and that includes our Australian sessions. You'll be entered one time to win for each session, $350 Amazon gift card given at the end of March. The same thing will happen between April and June, and that's compliments of our sponsor, SentryOne. So, session recordings, if you want to make a picture of this screen, it'll keep up with where our archive is. From that, if there's any slides or scripts that you want, we'll have that there, or you can just go to our YouTube channel and subscribe to that, and you'll know the minute that I have a presentation uploaded. Okay. Oh, okay. That's it. So we're on to the presentation. Kevin will be giving this presentation. It's a great presentation for a good overview of all of the things that are used on SQL Server to troubleshoot. In fact, I remember reading in his abstract at PASS one time that this was a great session to go to early in the summit, so you could get a feel for all and a flavor for all of the different things that were out there, and indeed it is. I think you're going to really love it. Kevin has been with PASS since the inception, and he's been with it for a long time. He's an MVP. He's the main guy with our sponsor, SentryOne, and he's one of the better speakers out there. He's also an author. And what I'm going to do now, though, is I'm going to turn it over to Kevin, and let's see if we can work this out. Let me move it over. I'm going to make Kevin the presenter.
All right. Can you hear me okay?
You sound good.
All right. Now let me show my screen, and then we'll be able to make some headway here. All right. let's see, what screen do we have showing at this point? It's quite slow.
That looks like it looks slides, yeah.
Yeah, it's the presenter
Okay.
Presenter view there. So let me pull up the other one. There we go. All right. So thanks everyone for coming. I know you've got a lot to do and you're busy, so I really appreciate that you've carved some time out to spend it with me. As Steve mentioned, I was one of the original 9 founders of PASS way back in 1999 and was president for 2 terms back from 2004 to 2008. And I'm still very, very active in the SQL Server community. I'm at, well, this is actually our old name. We are SentryOne now, since we have products not just for SQL Server. We also have products for Windows and virtualization. The best of breed for monitoring, alerting, and performance tuning. I'm very active on Twitter and Facebook and LinkedIn, so again, we can connect here at KE Kline. So if you're on Twitter, and you should be, because the SQL Server community is very active on Twitter, then please connect with me. And you'll see I tweet a lot, not only about SQL Server, but about DBAs, about professionalism, and about data science, which is one of my passions, if you will. All right, so what are we going to talk about today? The first thing I want to tell you about is a little bit about my company. I mentioned we make monitoring and performance tuning tools. That's what we do day in and day out, but we're very engaged with the community. So we have 2 blogs, one that's strictly about SQL Server, that's SQLperformance.com. We have another that covers SQL Server and, for example, our community activities, what events we're going to, where we're speaking, what are they, T-SQL Tuesdays, those sorts of stuff. I do a series of webinars, usually 2 a month, and those are posted after the fact at SQL Century TV. If you would like to get a lot better at SQL query tuning, spend a little time at SQLCentury.tv, because we have this free, very, very popular product called Plan Explorer, and so there's probably 12 to 16 hours worth of query tuning videos about how to make your SQL queries perform better at SQLCentury.tv. And since Plan Explorer is so free that we don't even ask for an email address, and a lot of those we use Plan Explorer to show you how a query performs, because that's what it does. It makes it very easy for you to see how your SQL queries are performing and what's going wrong in there. It'll use color coding and show you the red part that's not performing well, and other things like that. We also have a website that's dedicated to answering your questions about SQL statements and why they may not be performing well. So if you have problems getting something to run well, try answers.sqlperformance.com and we'll give you some free help. Now also, we have a series of ebooks that are normally $10 in the Amazon Kindle bookstore, but we will give those to you for free if you go to centryone.com/ebooks. And this includes many of the best known authors in our business, some of the names that Steve mentioned just a few minutes ago who will be speaking in the next couple weeks, next couple months, people like Paul White, Paul Randall, Kimberly Tripp, Aaron Stellato, the best of the best.
These are definitely really good books. I mean, everybody should take advantage of this.
Oh, thanks, Steve. Appreciate that. And they're not little throwaway pamphlets that are 30 pages long. The shortest is over 300 pages long, so they're the real deal. All right, so that's my commercial. Oh, and just quickly, here's the one that I wanted especially to draw your attention to, Plan Explorer. That's the one that's completely free. We have hundreds of thousands of users, so I encourage you to just take advantage of this free tool. If you're in the market for monitoring and alerting products, then please give us a call, but everybody should have that Plan Explorer. All right, so what are we going to talk about today? The topic is a methodology, a foolproof checklist, and those words are synonymous. Methodology is a fancy word for something as simple as a checklist. And so what I'm going to do is I'm going to take you through how I do my troubleshooting and kind of triage and performance tuning process. And it involves a variety of tools that SQL Server makes available to us. And So some of this we won't have time to get to. That's why I have an X over here by execution plans. We won't have a whole lot of time to dive into execution plans. But what we will do is talk about how you can very quickly, at least with a minimum of effort and the economy of motion, is what one of my instructors used to say. You know, with the least amount of motion and expenditure of energy, we can get to that root cause of a performance problem. And then we'll wrap up with some resources and other things you can take advantage of. So one of the things about SQL Server, and oh, by the way, I am colorblind, so I apologize if these colors are hideous. I can't tell whether they're great or not, but let's assume that they're not making you ill. You know, one of the things about SQL Server is that it has a lot of different places that give you information. There's error logs. You know, you can look at the execution plans. Maybe you're used to doing all of your troubleshooting as a developer, and you're using ODBC trace, you know, PerfMon and Profiler, and you know, all these different kinds of things, and they all give you information. The question is, what is the source of information that is most actionable through a series of sequential steps, right? And which ones, when done right early in the process, will negate the need to do additional work later in the process? And I found out through hard knocks, you know, through trial and error, that some places we could start at might not be the best place to start, because the information they provide isn't always actionable, or perhaps it even takes you down the wrong pathway and you wind up wasting time. So think of this methodology as either a sieve or like a filter. And so what happens is we have these big things that fall into the sieve or filter, like, you know, big SQL statements or stored procedures, but then we also have resource issues. Maybe we don't have enough CPU, or we have really old, slow hard disks. We have errors that might pop up in the log. But what we need to do is quickly eliminate things that may not be the problem and move on to a tighter and tighter weave in that sieve until we get to that root cause. And so that's what this checklist is all about. So my checklist involves 6 steps, and we're going to go into each of these in a little bit more detail. You know, we'll have a slide for some of these. Now, another thing I also want to point out is that I have a lot of hidden slides in this, so you'll want to download the slide deck and review the notes, because there's a lot of stuff in there over and above what we'll have time to talk about today. But 2 things to note here. I'm going to talk about step number 1 and step number 6 at the beginning. So the first thing to keep in mind is this concept of following up. One of the things that you know, I made a mistake in, you know, as a young and naive DBA moving over from being a developer, was I wasn't very methodical about the, you know, I wasn't very deliberate, and I didn't really plan ahead about how I reacted to circumstances. And so if a fire came up, a lot of times the last thing I would do in my checklist here is instead of following up here, I might have put celebrate. You know, it's like, woohoo, I fixed the problem. This is great. And then a year later, I'd have the same problem again. And I didn't remember exactly how to fix it. And back in those days, back in the early 90s, there wasn't a lot of documentation. In fact, most of the errors that you might have encountered inside a SQL Server probably didn't have any, you know, well-defined remediation for them. So you had to figure it out on your own. So 2 things came out of that in this follow-up step. The first is write up a post-mortem. That means after death, if you're into Latin. But in this case, what we're talking about is after that error happened, write up the circumstances of the problem, the performance issue, describe it, and then describe your resolution. And this is the way you build up institutional knowledge. This is the way that if you bring in other DBAs, you're the only one there now, you bring in someone else, you've got kind of a notebook, or maybe it's a OneNote or Evernote kind of folder that has all of these resolutions for things that happen inside of your environment. That's the first thing you want to do in a follow-up. The second thing you want to do in a follow-up is you want to build some form of alerting, and I'll show you the rudimentary and free version that's built into SQL Server, but you want to have some kind of alerting that will tell you about it when it's in its early stages of starting, so that the next time this happens, you will not get burned by it, right? And so here's kind of the moral of the story, if you will. Many of you may be DBAs. Many of you may be developers, and so you're trying to figure out how to better do this troubleshooting. But if your responsibility is to keep the server up and running, one of the things you'll notice is that there's not a lot of love from the management, the top level managers of organizations where you're a cost center. You know what I'm saying? So in the company I used to work at, we had a lot of consultants who knew the same thing or even less than what those of us on the DBA team knew. But when they'd have a really good month, their manager would come down and give them a high five and say, oh, keep it up. You're billing, a large number of hours. We love it. You're doing great. But to the DBA team, the managers never came down and said, less problems than ever, team. You're doing wonderful. This is super. The best we ever got was kind of a benign neglect, right? They're like, oh, hey, yeah, how's life? They never actually said, you're doing so good. On the other hand, when things went wrong and we had a trouble situation, we had to do firefighting, they remembered our name first and called us first, and they were already angry. We'd already begun to lose credibility, to lose prestige in their eyes. And so one of the things I realized is that if you're running your environment and doing troubleshooting by how much your phone rings, you're doing it wrong, because that means you're already in a deficit of that credibility and prestige. You have to get ahead of it if you want to build up your team to be seen as a team of highly competent professionals. Okay? So that means you have to build alerts that will tell you when problems are going wrong so you can fix them before the end users ever notice. And if you don't get them fixed before the end users notice, what you can do then at that point is you can give them an ETA, an estimated time of arrival, if you will, of when it's going to be fixed. And that, again, changes the dynamic of that conversation. So instead of them saying, I'm really upset, your database is broken again, now you can say, it's going to be fixed in about 30 minutes. And the users often will be surprised. They'll be, really? Oh, okay. Most of the time you didn't even know it was a problem. So it changes the dynamic. So that follow-up doesn't have its own slide, but that's an important part of this process. Now let's talk about the next step-by-step bits as we go along. So what is the shortcut? And the shortcut is keeping track of what's in your environment and comparing to see if anything has changed. All right? Now, what I'm talking about here is that I don't mind, as a DBA, if we have a planned rollout of code. Our applications are out there and they're doing their work. That's not a problem at all. What we want to be very careful of is that anytime there is unexpected changes, unanticipated changes, we're actually introducing risk into our application and into our database. And so this is the sort of situation in which we want to be very careful. It was one of the things where when I became a DBA, I realized suddenly that as a developer, I was actually making life hard for the database team, because I liked to roll out stuff as soon as I got it finished and like to have it in production. And if that's not planned, and then there is a problem in rolling back, you'll be in a lot of trouble. And if you've ever had to do a partial rollback on on one small bit of code, you'll kind of sympathize with me. This is a problem. So here's what I started to do. I started to keep track of what has changed in my system. And so the first thing that I had to do was I would have some really smart lead developers, for example, who would see that for some reason this particular server didn't give them all of the memory, or it didn't have the max degrees of parallel setting the way they wanted it. So they'd go in and change it themselves. And that's not okay. That has a lot of downstream repercussions. And so one of the things I started to do, and I'll show you over here in a demo, one of the things I started to do was I started to keep track of things like the SP configure options and the database options of my different databases. And so what I would do is I'd take a hash of all of those values, and if that hash is changed over a particular period of time, then I would know that someone has changed things without my permission. Okay, so what let me go ahead and execute this here. And so what you can see here is I've got a hash value now that I would save as the daily consistent value in my SQL Server database. And then I'd set up an MSDB job to run this every day and see if it's changed since yesterday. And if it has, I can go back to the leads who have heightened access on the computer, and I could say, hey, what's going on? Why did you change something? You're supposed to do that with my foreknowledge. Okay, so you can set that for, with a slight change here, you can set that for the database options, and in this example, it is set for the SQL Server configuration options. So that's the first thing I would do. The second thing you can do after that is you can actually use something called DDL triggers. And there's a couple ways to go about this. There's another method you could use involving extended events, but I personally like DDL triggers because they've been around and supported for a very long time in many versions of SQL Server. In my case, what I do is, let me go to the bottom here and I'll clean up from the last time I ran this example. Let's see here. Oh, I'm in the wrong database. All right. So what you have with DDL triggers is the ability to keep track of any time a SQL DDL statement fires. That DDL means the data dictionary language, so that's any time a create, alter, or drop statement fires. So here I'm going to create a table to keep track of all of the DDL events that happen in my database. Let's create that. Oh, that's probably the one I needed to drop. And then I'm going to grant permissions on that to public so that anybody who creates a table will be able to write these records into the particular into that MSDB database. Now I'm going to go ahead and go over to AdventureWorks, okay? And I'm going to create this trigger. And notice here I've set it by database, but you can also set this for the entire server if you want to be a little bit lazy, I guess, and not specify exactly which you want. Now I'm going to tell it to insert a bunch of data as it happens, as it occurs when a user executes a DDL SQL statement. Okay, still got that object in the database. Now also as a side note, I recommend that you don't disable or you don't drop the trigger if you need to turn it off for a while. What you should do is just disable it if you want it not to be active for a certain period of time. Let's say you have a rollout on a Friday afternoon, so disable it and then re-enable it when you're ready to get back to regular business as usual. That way it'll be available for you. So now what I'm going to do is I'm going to go ahead and show you the test here. I'm going to create a table, I'm going to alter the table and drop it. So all three of those DDL statements, I'm going to go ahead and execute those. And so here I'm going to go ahead and query that data out of the MSDB table that I just created. And so what we'll see here, if one of my developers went in without me knowing about it and they were working late on Tuesday evening and 11 p.m., I see that someone has actually issued a alter procedure statement. I would see that down here. And so when I come in and all my users are blowing up my phone saying the database is really slow, the first thing I do is see if anything is different from last night. And I check this table and say, why did somebody changed a stored procedure in here? And then I'd go take a look at the code and see, oh, they created a big table in TempDB that flushed a bunch of other important data out of TempDB that was used for some, I don't know, let's say ETL processes. And so that caused all kinds of havoc there in my production systems. And so I could come back to those developers and I could say, hey, what happened there? That's not the way we're doing things anymore. So let's talk about this unplanned change that you put over on us, right? So that's the first thing to do in your checklist, is to make sure you know what is going on in terms of your environment, and you minimize the risk that your system might incur by having unexpected and unplanned changes. Many times that's the problem. Now the next thing we want to do, again according to that checklist, is we want to see if the problem is inside or outside of SQL Server. And that means the Windows application error log. So what you need to do here, it'll take less time than it will for me to explain the concept for you to actually go and look. But what you want to do is you want to make sure that no other problems outside of SQL Server are showing up in the event log. The reason I make this the first step after checking to see if anyone's changed anything is because there have been times when I spent half a day trying to troubleshoot a particular problem because I thought it was something related to, some new software that the dev team rolled out, when in fact if I had just gone and done this first, I would have seen that there was a multitude of Active Directory errors in the SQL Server, in the Windows log there. And so I would have known it's not even a SQL Server problem. It's something I can hand over to the Active Directory team, the security team, and in fact I'm done. What better way to fix a problem than to not have to fix it, but to give it over to the team that's actually responsible for it. But we can be proactive here too. So SQL Server has an error log, and it has a log as well for the SQL Server agent. And one of the things we can do is we can use this really cool feature inside of SQL Server called the SQL Server Agent Notifications. And so I want to work smarter and not harder. And so one of the things we can do is we can have SQL Server tell us whenever an error occurs inside of SQL Server. So that first step is, has anything changed? The second step is it inside or outside of SQL Server? If it's outside of SQL Server, we can give it to the team that's responsible for it. If it's inside of SQL Server, now we need to figure out, is the performance problem that we're getting calls about or that we're aware of, is it caused by an error inside of SQL Server? And the good thing about that is if it is caused by an error, we may not have to do anything else but to fix that error. It gets more difficult. We have to go to another layer of the sieve, if you will, if we find errors and they don't correlate to the problem, or we don't find any errors at all. But sometimes if you find an error like, say, a 605 error, which says this error could be raised for any table if the allocation unit ID of the page doesn't match the expected allocation unit of the ID, or allocation unit ID. So in general, this signifies page or allocation corruption. Like, oh, wow, that's no good. I'm going to have to do a DBCC, check DB on that, and I may lose some data. Or it could be something like an 1101 error, in which it just says, we tried to allocate some more space for this database and we ran out of space. So it sounds really bad that having an error may come up, but in some cases it's actually pretty good because you're done. You don't have to do a lot of additional research. All you have to do is check that one particular fix that one particular error, which is described now. Almost all the errors are fully described in the SQL Server documentation, so you can make headway there. It's really, really difficult at times if there's no error, or it doesn't seem to correlate at all with what the users or the application is experiencing. So let me tell you about that work smarter, not harder concept, and that is this idea that SQL Server has this error notification built in. So let me pop over to Management Studio, and if you'll notice over here on the left-hand side on the Object Explorer, we have the SQL Server agent, and the first thing you have to do is you have to create an operator. This is the person or group of people who will get your messages. Typically, that's what you're going to want to do. You're going to want to get an error message in email to let you know what's going on. So you create one of these particular operators. I encourage you to actually use groups and not use specific individuals' names, because I can't tell you how many times I've seen a situation in which a particular person leaves the company, or they go on vacation for a week, and the person who's supposed to be getting these doesn't get anything, and the person who wants to be on vacation can't go on vacation because they're getting peppered with these emails constantly. So you might have, like in my old job, we had DBAs or DB admin at nameofthecompany.com, and that was set up for us in Outlook, and in Exchange we had that, and everybody could check that one particular group. You can define working schedules for that group. You can tell how you want them to be contacted, which of the different error messages that group will be contacted for. You could have a first tier and a second tier. You could have a first shift and second shift and so forth. Then you want to come over here to the alerts tab. Once you've got your operators set up, come over to alerts, and you want to create an alert for at least severity levels 19 through 25. Because these are serious errors. These are errors that have caused, 19 is less serious, so maybe a stored procedure that was expecting a parameter didn't get one, and so that procedure failed, it stopped. But once you get to 23, 24, 25, a database has been marked as suspect, or something very important has found corruption. So you definitely want to have those for the different alerts that you have. There's actually three kinds of alerts you can create. The first is an event alert, the second is a performance condition alert, and the third is a WMI alert. The event alert is the ones that I rely on heavily. So you would say severity level 18. So severity level 18 has some important deadlock errors, so let's go ahead and add that one. And the response will be to notify our operators, right? And then I say OK, and I've got that particular one. The option would be to create other alerts, for example, in that follow-up step. Let's say, for example, when our SQL Server had a problem, we noticed that it was because of deadlocking. Well, there's a PerfMon counter for deadlocking. So what we can do is we can say, I'll call it deadlocks, and we can come down here and you can define a counter on anything related to SQL Server's behavior. So we're going to say locks. The counter itself is number of deadlocks. We're going to say for the whole instance. And we're going to say if that counter rises above 5 per second, then I want you to send me an alarm, okay? Because it's about to go bad, all right? The other option that we have here is a WMI alert. WMI alerts are related to Windows and the file system and so forth. So one of the things you can do here is you could say, okay, so the dev team wrote a Windows service that runs on the server. I want to keep an eye on that service and make sure it never uses more than 10% of the CPU on the system. So that's the kind of thing you can do with WMI. You can monitor and alert on things outside of SQL Server. All right, so I'll say okay to that. So now I've got all these different alerts. They're rudimentary, and of course if SQL Server agent ever stops working for whatever reason, you lose the ability to have those alerts, but it's a powerful way to let SQL Server tell you when there's something wrong rather than you trying to figure out and going out and reactively looking at everything that might be going wrong on your SQL Server. So that's how you stay ahead of the game. Otherwise, if you have more than one or two SQL servers, you'll never stay ahead of the game. Now, that's kind of the rocks, the big boulders that come through our troubleshooting process, but it gets more fine-tuned after this. And so the next thing we have to do, if we don't find any big errors and nothing has changed in the system, we have to start going deeper. And the way we do that is with wait statistics. And wait statistics tell us where SQL Server is encountering a bottleneck. And that is really, really important. One of the things I hear people say very frequently is they'll say, oh, well, we're having performance problems and we haven't quite maxed out the SQL Server memory on this box. So we're going to add more memory to it. Well, if it turns out you've already got a server that has no memory bottlenecks, adding more memory is not going to help. So SQL Server has this functionality that enables you to figure out if that's the case or not. Wait statistics are revealed by a dynamic management view, a DMV, inside of SQL Server, and it aggregates all of the different things that SQL Server is waiting to complete before it can go forward and finish what the users request. And so the analogy I like to use is that SQL Server, actually let me go forward one step. Imagine that every CPU you have in your SQL Server is kind of like a drive-through window at a fast food restaurant. You know, it can serve one person at a time. And so you have all these users, and some are asking to insert some data into a particular table, and others are doing updates, and some are doing deletes. And in order to complete your particular transaction, SQL Server has to go behind the counter and collect some stuff and bring it back to you, and you know, hopefully it does that in a fast and happy way. But sometimes something goes really weird, it goes wrong. And maybe it's because we asked for it wrong, or maybe because SQL Server doesn't have enough of the resources that it needs to process that query. And so that's what happens in the schedulers of SQL Server. They ask, someone connects, they get a SPID, a system process ID, and they run for a second, for a little time slice, a millisecond, telling SQL Server what it is they need. And SQL Server says, oh, okay, you need locks. Let me, you know, you need exclusive locks to do this update. Let me see if any of the things you're asking for are currently exclusively locked. Meanwhile, other people are running on their own threads, and if the thread is runnable, that means that they have everything they need except for some time on the CPU to get their work done. On the other hand, I just landed on the CPU. I asked for some exclusive locks, and it said, no, I don't have exclusive locks right now because other people have exclusive locks. Just like when I pull up at the fast food aisle, you know, or the fast food lane at the McDonald's, they don't have something that I need. Like I have a big family. I've got 7 kids, so there would be times where we'd pull up and they'd say, you know what, you're going to have to pull forward and wait because we don't have any French fries at all. So, you know, same kind of thing here. You have to pull up and wait inside a SQL Server to get those exclusive locks that you want. And what happens then is you're put into the suspended queue, and you have to wait to get those locks that you need, exclusive locks. Meanwhile, someone who's down here on the runnable queue, they're able to move up and become a running thread on the SQL Server. And so let me show you a little bit of a demo of how SQL Server reveals this to you. There's 2 ways they do this. The first is through a DMV called DMOS, waiting tasks. Okay. Now this shows you at the individual SPID level what is happening with all these different sessions, right? The other is through the DMOS wait statistics. So let's go to demo on that. And so this is the one that goes by SPID. So I don't really have anything running at all actually on this server at the moment. But here this is showing all the open SPIDs. Typically any SPID below 50 is going to be a system process. Not guaranteed to be the case, but usually the case. So we can, and here's one saying it's number 29. I'm sorry, it's number 73. That's doing some stuff on the transaction log. It's waiting on the transaction log to finish writes. So that's the one that goes by session ID. But usually, if I'm having a problem, performance problem on my SQL Server, I don't want to know by session IDs. What I want to know is by broad categories. Is my wait related to memory? Is it related to disk I/O? Is it related to locks or blocks? You know, what's the category that I could put it in? And so this is a query that's written by my buddy Paul Randall, and you can see all of the details here about how to get that that code, and it's also in the downloadable zip file of this presentation. And so what he's done here is he collects a lot of really useful information about the wait stats that tell us things like how long in milliseconds this particular wait stat has been waiting. But it also, you see, has got a long kind of not in block of wait stats that it wants to leave out. And the reason for that is all of these wait stats are things that are part of the natural organic processing of SQL Server. And so what we mean by that is in order for SQL Server to run, it has to do things. For example, it issues checkpoints by default at every minute as set with the recovery interval setting. So we don't really need to check the checkpoint queue and see what that is right now, because SQL Server is going to do that all the time anyway. Paying attention to these and being worried about these would be the same as if like a marathon runner ran straight off of the track in the middle of a marathon to their doctor's office and said, "Doctor, I need you to stop this horrible thumping that is happening inside of my chest." And the doctor would say, "No, no, no, no. Actually, you want that to happen. Those are very important. That's a very important thing." So same thing here. We want to ignore the things that are natural, that we want to happen all the time, and only pay attention to those things that are provoked by user activity. And so when I look at this particular SQL Server, I see that I have a trace write, and that's okay. I'm not worried about that because I actually defined for myself a more extensive trace write on this server, so it's doing a bit more. And that's taking up 41%, almost 42% of the weights that are happening on this little demo box that I have. But then after that, my number 2 weight statistic is CX packet weights, which means parallelism. Then after that, I have lock mutex exclusive locks. So that means it's actually waiting on insert and update, probably update statements or possibly delete statements. Next is lock mutex shared. So again, whenever I see locking, that means to me probably either a coding problem, developers didn't code this very well, and or an indexing problem. So the clustered indexes are locking too many records at a time, or perhaps a non-clustered index are locking too many at a time while other people need to get to those records, and they can't. So they have to wait until those exclusive locks are released. And so on down the list we go with these different important kinds of issues that the end users are experiencing. And so if an end user comes to me and says, I think we should throw some more memory on that box, but all I see are lock weights, then I would know it's not going to help. Throwing more memory on there won't do a thing, because how SQL Server locks has everything in the world to do with how the code is written and how the tables and indexes are defined on that SQL Server. So this gets us one step closer to finding out what that root cause is. And now we know we need to focus with these lock problems. We need to focus on the application and the database design, and we can start to look at it from there. Okay, now what do the top weight stats mean? Okay, so I'll just give you a quick explanation. I'll also point out that in the notes there's a lot more detail about what these different weight stats mean, and then also I want to point out that Paul Randall, again, this is in the notes, but Paul Randall has a great resource on his website at SQLskills.com that goes into a lot of detail about all the different weight statistics. But commonly what we're going to see in most SQL Server databases that I have worked with, applications that I've worked with, usually we see I/O weights pretty high on the list. And so if we see page I/O latch, and here it says X, but that's like a parameter. If it's X, it means exclusive, but if it's S or SH, that means it's a shared latch. And so what this means is loading data from the I/O subsystem up into memory is causing us to wait. And that could be for any of 2 major reasons. One is we don't have enough memory, and so it's constantly having to buffer in and out of memory. Or 2, the I/O subsystem is too slow. So that's a very kind of clear thing to diagnose. Similarly, if we see write log or log buffer weights, then our transaction log is either on a subsystem that's too slow and can't keep up with it, or it's getting bombarded by too much activity, or maybe transactions that are not releasing fast enough. They're holding on opening transactions for too long. Okay? So again, don't have time to go into all of these, but you will note if you go and look at the library of all the different presentations in the DBA Fundamentals track that there is some sessions, previous sessions about weight statistics, so that just go into this one topic. So you can get that from the DBA Fundamentals group, or you can actually go to SQL Century TV. You can download the slides and the scripts for this session, as well as watch a video as well there, so you can get all of that information again. All right, so let's move on. Lot more to talk about. So I've figured out what the weight statistic is. You know, let's say, for example, I know that it's a locking problem. How do I get to that root cause? Well, there's basically two ways, and this is sourced from my buddy named Bob Ward, who's the top guy in the Microsoft SQL Server support team. Now he's CTO, I believe, of, is it SQL Cat, perhaps? But what happens is we've got a situation in which we have, you know, all kinds of complaints, right? We've got my SQL Server is slow, my query is slow right now, or maybe my query timed out and never finished. And so we're able to diagnose this to the actual root cause by a couple different paths. One path, which is my preferred way, is to use a combination of Profiler and PerfMon, and I'll demo that next. The other path is to use the dynamic management views, and I'll show you a little bit more of each of these, okay? One reason I like PerfMon and Profiler is that it works on every version of SQL Server since about SQL Server 7 forward, whereas DMVs only introduced it around I shouldn't say around, they were introduced at SQL Server 2005. You know, this is a newer way to do it, but you can always use Profiler and PerfMon. I have a little asterisk by the performance dashboard, the activity monitor in SQL Server. I don't actually recommend you use that. The reason for that is it's really high overhead. If you have a server that you know is not crippled due to exhaustion of resources, then you can open that up knowing that, you know, there's plenty of headroom for you to run the activity monitor, and you can use that to troubleshoot a problem. So let me show you a little bit more about going through PerfMon and Profiler. So, and it doesn't have to be after the incident. It can actually be during the incident, but this also works great while the incident, after the incident has occurred, because what you can do is you can use PerfMon and you can record the data that PerfMon is capturing to a file and save it to a file. So this is what PerfMon looks like, and you can define a set of PerfMon counters that are essential for monitoring SQL Server, and you can watch it percolate, you know, across the screen. If you're sitting on any of these counters in the lower part of the window and you press Control-H or the highlight button, depending on what version of SQL Server or Windows you're on, it will turn that line really, really dark black so you can see it a little bit easier. I just tweeted out, by the way, a blog post by Alan White, an MVP named Alan White, who's also part of the PASS Board of Directors, and he had a blog post about the top 15 Windows PerfMon counters you should monitor on an ongoing basis. So, and that's at blogs.sentryon.com if you want to read that. What are the 15 things you should put in here? It's also in my notes. So again, download the slides and you'll see what are the 15 things I recommend in the notes. And so it will record that information as it goes along. Then what you need to do is open up Profiler, and you can also use XEvents in some circumstances, but not all circumstances. So I'm still sticking with Profiler right now, probably for the next release or two, until they update the tooling for XEvents that will make it a complete replacement for Profiler. Profiler doesn't work the same way as PerfMon does. PerfMon collects information about number of times things occur over time, like deadlocks per second or how much memory is used per second. Profiler is kind of a trigger-based system. So as it fires off, it keeps track of different things that are happening, say queries or update statements or delete statements or stored procedure invocations. And it tells you when they started, when they ended, and how many resources they consumed. Now, when you use Profiler, I want you to do the same thing you did with PerfMon. You record it to a file. To save resources, Profiler can be heavy on the overhead. So what you can do with Profiler is you can actually not use Profiler. What Profiler does is it invokes behind the scenes server-side stored procedures that do the traces, and I'll show you that in a second. You can even set those stored procedures once you collect them from Profiler. You can set them to auto start so that it will always have that server-side trace running for you. So let me show you the demo of what you get from these two together. First thing you want to do is you start Profiler, and then you invoke the template tab. What kind of trace properties do you want? And you can choose the default one if you want, and you want to save it to a file. Don't do this save to a table right now because you won't get to use the secret ingredient in this recipe. After you've chosen the trace properties, then you can go to this Event Selection tab, and you can change anything that you might want to. Now, the default is okay, but let's say, for example, you want to know not just when someone logs in and logs out, and when a statement is started and completed, but you want to do something else. Maybe you want to know when a service broker action happens or something like that. If you add anything in here, make sure that you capture the start time and the end time. That is essential. The second thing you can do is to reduce overhead, you can filter some of these things out. So what you could do is you could say column filter, and you could say, column filter by duration. And you could say, don't capture any SQL statement that takes less than 3 seconds to run. So that would really reduce the amount of overhead. Or you could say where the database, and it's not on this list of columns here, but you could say where the database is only equal to the main user database and TempDB. So ignore all the other databases that exist on this system. Okay, so that determines everything that Profiler will capture, and as it captures things, you click the Run button, and it starts to capture your data, and it'll look like this. You'll see a batch started, and it's selected a username, what have you. When you're ready, click Stop on both the Profiler and the PerfMon traces, and then what you're able to do is you can open Profiler and load in the trace file. That will show you everything you've just collected. But a feature that is hidden before will also show up. Import performance data. And what that allows you to do is to import the PerfMon trace file that you just collected. And it's pretty awesome. What you get there is an overlay of all of the different transactions that we're firing off and all of the different resources that were being consumed. And so let's say this particular line right here that you see kind of spikes upward. Let's say that's the number of page stalls. Well, here it's page splits, which is a pretty good indicator of I/O, some serious I/O. But let's say it was page stalls, which means that the read activity actually stopped on that. And it suddenly spikes upward. If we were to click on this part of the graph right here, it would take us up above to the specific SQL statement that caused those page stalls to go way up. It's like, wow, now I know exactly what stored procedure to troubleshoot or tune. I've gone straight to the root cause of that problem. It's very powerful. As a side note, I do have a blog post that fully diagnoses that fully documents this process. So if you're trying to keep notes and trying to keep up with it and you're finding you can't do it, don't worry. I've written a blog post that takes you through this whole process, and we'll walk you through it again. And I've got a reference to that at the end. All right? Okay, now, when I want to use the other path, and at this point I just said one is post-problem and the other is during the problem. That's a little bit expansive. You can use either one during the problem. You can use either one after the problem. But the thing about dynamic management views is that they typically aggregate values since the server was last started, and they also only track what is happening right here and now. So that that can be problematic. So that's one of the reasons why I recommend that you use DMVs as the problem is happening. But they do tell you amazing amounts of information. You can find out all kinds of things. So in the previous query where we looked up the dynamic management view on wait stats, and we saw perhaps that it was a CPU related wait, we could do a follow-up query to see what SQL statements were generating the most CPU. We could do a SQL statement to say, okay, I noticed that I've got a memory problem. Things are, you know, my buffer cache hit ratio is low. What are the 5 biggest objects in the cache? You know, so you can use your DMVs to get to that kind of root cause. By the way, don't use this regularly, but there is a statement that will allow you to clear out the wait stats and set them all back to 0, but don't use that. Now, again, there are a bunch of DMVs that are essential to troubleshooting specific issues on your SQL Server. I'm going to show you in a demo in just a second, but the good thing about all these DMV queries is that you don't have to write a one of them. Glenn Berry has collected the best that are out there in the blogosphere. So if you saw a wait stat that came up, you know, as one of your top wait stats for I/O, then you might do a query on the DMIO virtual file stats to find which, if any of the particular files has, you know, the lion's share of the weights. Maybe you want to look at it by the different queries and see which of the queries that are currently active have the most I/O on those queries. So let me show you that as well. Let's hop over to that. Actually, let me show you a couple things. The first thing I want to show you is that when you're in Profiler, you can save your trace, right? So you can actually go in and create the trace that you want in Profiler, and you can say, you know, just look at TempDB and my main user database and only collect queries that run more than 2 seconds, and then you say save the you go to the file and save the trace, and it will produce an output file that looks something like this. So you can see what the trace definition is. You can see all the different collections that it's put in there. What, you know, the you know, it's got some error handling in there. So that way, here's TempDB, here's TPCC. So you can tell it, hey, I don't want everything. I want you to just collect some of it, and it will it'll help you out a lot. Don't have to learn all of these stored procedures. Another little utility I wanted to show you that is in the collection of scripts for this presentation is Tim Radney has written a blog post over on SQLperformance.com, and what he's done here is he's actually created all of those severity level error messages and notification settings, so that you don't even have to go through and create all those yourself. They're all in here. Plus he even added some for one of his favorite error messages that is particularly bothersome to him. So again, you don't have to invent the wheel. A couple of nice DMVs to use. One thing that's kind of cool is anything inside of PerfMon is that relates to SQL Server is also inside of a DMV called DMOS performance counters. So here's one for the buffer cache hit ratio. And so there are some other examples in there that will tell you what your buffer cache hit ratio are. Let's look at this one here. I'll just go ahead and select them all. What the target server memory is and the total memory, and we can see the page lookups per second, for example, and how fast that's happening. Again, if I wanted to use the DMV process to figure out what was most expensive on my system, you know, what queries could be that root cause. There's a query here originally written by Jimmy May over at SanDisk, and so what this one does is it looks at all your different queries and tells you what are your top 25 queries, and in this case this is by the total worker time. So if we go over to that column here a little bit more, total worker time, you know, this is the number of times it was executed times the amount of time it takes to run. So that tells us how much time overall is taking, but maybe we don't have a CPU problem. Worker time relates to CPU, so maybe we want to do this by I/O. So let's change it out. I'll comment out the total worker time, and I'll go by let's go by physical reads. No idea, sorry, no idea if this is going to retrieve a lot of information, but let's see what it says. Okay, so I have my SQL Sentry monitoring database, which I have running on here, and then there's some queries in master and stuff like that happening. So not as exciting as I was hoping it would be, but you get the idea. Whatever is active on that SQL server, you can find out who is issuing those queries, what those queries are, and you can troubleshoot them. Right, so it takes you right to that root cause. And it may not even be a query. It could be a backup process, or it could be, you know, any number of things. But again, once you see what that weight statistic is, if it's a I/O weight statistic, you might want to then dive down and look at the virtual file stat DMV and see where your latencies are. And this will tell us in milliseconds how long my write latencies are. 22 milliseconds. Well, that's very, very fast. But if it was 220, that's not very fast. So it gives us an idea of where that slowness might be if it was in one or multiple databases. Here's another set of examples over here. Let's see, sorry, wrong one. Oops, all right, got that one. Now I wanted to show you the dynamic management queries that Glenn Berry has put together. So here we might want to see what the buffer pool usage is and see how much memory we have being consumed. Who's consuming all of this memory, you know, by database? So the monitoring database and then some of our others, right? So again, those DMVs can get you closer to that final answer of what is the smoking gun on your SQL Server. Now, once you identify what that specific SQL query is, let me go back here. We've looked at the error log, and that tells us two things. First of all, very quickly it'll tell us if it's outside of SQL Server, if we start to see Windows errors. If we see SQL Server errors, we know that we have to fix the SQL Server errors, really, before we can fix too much else further downstream. Because, you know, if we're getting disk errors and corruption errors on a database, it doesn't make a lot of sense to make a, you know, go to performance tuning on a specific query if the database is corrupt. So we figure out what those errors are and resolve those. After we resolve errors, then we look for the weight stats, and we get a prioritized listing of where our system is bottlenecked. Then based on that, we use either PerfMon and Profiler to correlate the exact SQL statement or statements that are causing those excessive weight stats, or we can use those dynamic management views to get to the exact SQL statement that's causing those weight stats. And then from there, it's resolution time. And what that means is we need to open a tool like Management Studio or Plan Explorer, and we need to try different alternatives to the code that is put in place there to see if we can get those to perform better. So an example of that, and which is also in a lot of those videos I mentioned on SQLsentry.tv, one example might be that you've got a bunch of queries written with subqueries, you know, where the where clause says, you know, where my value is in and selects from a subquery. But you could rewrite those as joins a lot of the time. So maybe that would give you a different performance characteristic for that. You might also, you know, use a hint, or you might tell it to use a, you know, an explicit hint to use a hash join algorithm instead of a nested loop. Or you might use a left outer join instead of a, you know, a subquery, or you might use a union statement instead of an or. You just try your different alternatives, test it, see what its performance looks like, and find the best performing alternative. Okay? So that's how we get to resolution, is trying out that code, fixing it. So it's a simple step-by-step process. The only shortcut you've got is to know if something's changed. That's usually what's going to make the performance different today than it was yesterday. Next, you want to look at the Windows logs, the error logs, then drill down into weight stats, and from weight stats you can use PerfMon and Profiler or the dynamic management views to get to the root cause of that problem. And then you have to look at those execution plans. All right, one last slide, and that is some free tools that are great. I mentioned Glenn Berry stuff, but there's some other really, really good ones. Brent Ozar's SP Blitz. I really love Adam Mechanic's SP Who is Active. Plan Explorer, of course, I mentioned. And then if we don't get time for it, for questions, you can get a hold of me. It's Kline at SentryOne. And also I mentioned the blog posts that talk about pretty much what I talked about today, taking you through that whole end-to-end troubleshooting checklist in a, a fairly long article, but it's very detailed and shows you how to do everything. Steve?
Yes.
Do you want to take some questions, or how do you want to wrap up?
We've got a couple of questions. I've answered a lot of stuff. What's the impact on parallel queries if I disable parallelism?
Well, of course, the smarmy answer is it disables parallelism. Thank you, Captain Obvious, right? A lot of people are scared of parallelism, and that's kind of an inappropriate response. Parallelism for large queries is usually a good thing because we can split it up into chunks and it will perform better. Parallelism for little tiny queries is often where the problem comes in. There's two problems with parallelism. One is when it's on a tiny query, and one is when only one of the parallelized threads is taking a long time and all the others finish quickly. So for the first one, what I recommend you do is don't change the max degrees of parallel setting. Instead, change the cost threshold for parallelism setting. Different bloggers like different settings. I personally change cost threshold for parallelism to 30 from the default of 5. So that says SQL Server, instead of trying to parallelize any query that's 5 seconds or longer, only parallelize the really big ones that are 30 seconds or longer. So that will let a lot of small queries not be parallelized. The other way, I'm sorry.
Go ahead. I thought you were finished.
Yeah. If you look in the XML of an execution plan in Management Studio, you'll see, if it's parallelized, you'll see the different parallel threads, and it gives you a little bit of information on SQL Server 2014 and 2016 about how long it takes each thread to parallelize, to do their work. And if it's equal across all those threads, it's good parallelism. But if you find that one of those threads is way longer than the others, then that's a whole different situation, and usually that means that there's a database file problem and not a parallelism problem on that query.
Okay, this one is somewhat related to that. The user says that they have recently had flash storage installed for one of their servers, and they had been told that the max stop and the cost threshold for parallelism is not, you don't necessarily use the same settings as you do if you had regular storage. Have you heard about that?
So just quickly, that is true. Flash is so much faster than traditional hard disk I/O subsystems that what happens typically is your bottlenecks change completely. And things that were your bottlenecks go away, usually I/O in some way, and things that you never thought of that could be a bottleneck now become your bottleneck. So it's possible that, we took away all of the bottlenecks related to getting data loaded up from the disk subsystem, the slow hard disks up into memory, because now we have this really fast flash. Now what's happening is all these parallel reads are happening so fast that they're getting in each other's way. And so I don't know which vendor you're talking about. Some vendors have done a fantastic job of really testing and documenting that. So Pure Storage, for example, I'm really positive on them. So if it's Pure you're using and they recommend that, then I'd say absolutely believe it. Some of the other vendors I have not done as much work specifically around SQL Server, and so I would suggest that you should take those recommendations with a grain of salt until they can actually tell you how they came by those recommendations.
Okay. For instances that have unrelated databases, I'm not sure I understand. Do you have advice on how to use the DMVs?
Well, a lot of the DMVs are sortable, not all of them, but many of them are sortable by the database. So what you would want to do is do queries specifically linked to specific databases and look at it that way. one of the examples I showed was the I/O by virtual file stats, and so that'll tell you by database which are the busiest for I/O and so forth. So you can do similar sorts of things with CPU and memory usage. So you've just got to pay attention to all those different databases and make sure you're aware which are busiest and learn that.
I'm going to have this last question to kind of set you up to have a final little advertisement for SentryOne. When dealing with many servers, what's the best way to monitor those?
Yeah, great question. So I will say that thank you for that plug, Steve. You know, I worked in an environment in which I managed a few servers. You know, on day one I managed one, and then by the end of 3 months I managed 16, and then by the end of the year 40 SQL servers. And once you get to an environment that big, you're spending so much time putting out fires that you're never going to be a value add to the business. And that's really where you want to be as a DBA. So, so what you want to do is, if you can talk your management into it, you want to be able to get a good monitoring product so that you can actually keep abreast of everything that is happening on all of your different SQL servers at one time. It's very, very important to do that. You really can't do that effectively using the native tools unless you do a lot of additional coding, or you use some of the free stuff that's out there that it honestly just can't compare to the different paid products. So you know, I say spend $3,000 or $5,000 or $10,000. This is my personal belief, so that I can save $40,000 in value to the company. And that would be my recommendation.
I totally agree with you on that. I mean, I love this stuff that you can use, and I use it extensively, but when you get enough servers in your environment, you just can't keep up with it if you don't have something like that. And then for the really tough problems, you use these other things if the product doesn't work, but it's definitely worth it. Let's see, I think that's about it. You backed up one slide. This user wanted to see this last slide.
Yep,
so I think we have pretty well everything answered.
Okay, folks. Well, again, my email address is kline@sentryon.com. So if you want to continue the discussion offline, I'm always open to emails, and hope to see you at another presentation soon.
Thanks, Kevin. I mean, one of the things, and I recommend everybody take this session, if you go back and view it again, because we're getting ready to have some of the best speakers in the industry for performance for these different things that Kevin's went over today. And this is a great overview of it, of the different things you can do and how you can use different tools together. We're going to be going with some of the best speakers in the world talking about each one of these things. So really review this one and work with it, and we'll see you actually for the first one next month with Erin Stellato. So she's going to be going over, it's a little bit different from anything here, but she's going to be going over 2016's Query Store. So sign up for that. We appreciate it. Thank you.
Thank you.
Bye.